Okay, in this lesson, we are going to be going over the first little review section of the rational functions unit. So we're going to start by doing a little bit of review, some things to remember from grade 11 pre-cal. So when we're working with rational expressions, which is basically a polynomial over another polynomial, the thing that we need to pay attention to is our non-permissible values. So remember, these are the values of the variable that make the denominator equal to 0. So if we were looking at example 1, we've got a trinomial and a binomial. When you're looking for your non-permissible values, you're basically determining what will make x minus 4 equal to 0. So if you wanted to write that out, you could say x minus 4 equals 0, so x should say this cannot equal 0, so x cannot equal 4. Okay, now we also spent some time in grade 11 simplifying rational expressions. So this we kind of talked about in our polynomials unit, where our first step in dividing polynomials is looking for common factors. So if you look at this expression here, you can see what I've done is I've factored the top and I've factored the bottom, and I then have two terms that can cancel out, x minus 4 and x minus 4. You'll notice after I factored this polynomial, I also determined my non-permissible values. So in this case, x equals 4 and x equals negative 5 are my two NPVs. And then when I canceled these factors, I'm left with negative 3 over x plus 5. Now you also learned how to add and subtract rational expressions. So the key thing to remember when you're adding and subtracting rational expressions is that you need a common denominator. So your first step, as with most of these rational expression problems, is always to factor everything. So you'll see here that the first term here can't be factored or simplified at all, so I just rewrote it. The second one, I can factor the bottom. So I get 240 over x minus 5 times x plus 3. Now you'll see in these two terms, they both have x minus 5 in common, but if I'm looking for my lowest common denominator, I also need x plus 3. So you'll see what I did over here is I multiplied this whole term by x plus 3. And you can see that multiplication right here. Now at this point, when everything is factored, I also want to make sure that I state my non-permissible values. So in this case, I have non-permissible values of 5 and negative 3. Those come from the denominator. So once I get this common denominator and I multiply this 6x by x plus 3, nothing changes in this side because I already had that common denominator, both x minus 5 and x plus 3. Now I can just simplify this. So I multiply the 6x through, subtract negative 240. Sorry, you guys, just had an interruption. I had to pause my recording for a second. So here I was saying that you're going to multiply all of this through, so 6x times x, 6x times 3, and then you'll notice here you get a polynomial that you can also factor out a common factor of 6. And once you do that, you'll see you've got this trinomial x squared plus 3x minus 40, which you can also factor. Now you'll notice in the bottom, I just left the denominator. The denominator just stays the same. Leave it factored because in the end, once you've factored the top, you then have terms that can cancel out and you're left with your simplified expression. Now, I would definitely say adding and subtracting is the most work because of that common denominator. When you're multiplying and dividing, let's start with multiplying. When you're multiplying rational expressions, really all you need to do is factor everything and cancel like terms. So when you have these expressions here, you'll see that I factored the bottom of both. The tops were already simplified. I factored the bottom of both. And because these are all being multiplied together, you can actually cancel terms from each set here. So x plus 1 can cancel with this x plus 1, and x minus 2 can cancel with this x minus 2. Before you do that canceling, I should have said you want to make sure you list your non-permissible values. So that's 3, 2, negative 4, and negative 1. Cancel everything that's in common, and you're left with your simplified expression. Now, dividing is almost exactly the same, but remember, when we're dividing fractions, the easiest way to do it is to flip and multiply. So you're going to do something very similar. You're going to first factor everything, but then you're also going to flip your second term. So here I have x minus 7, x plus 4. That's already simplified. I don't have to do anything to it. Now this factors to x minus 5, x plus 3, and the bottom factors to x minus 5, x plus 4. So I did it sort of all in one step in terms of flipping. So I took the top and it flips down to the bottom, and the bottom flips up to the top, and then it becomes multiplication. Now I've made a little note for you here about the non-permissible values. You want to make sure that you determine your non-permissible values before and after doing this flip. So here, before I flipped anything, my non-permissible values were x cannot be negative 4 and x cannot be 5. Then once I did the flip, and here I've got it as multiplication, you'll see I still have that x cannot be negative 4, x cannot be 5, but I also have x cannot be negative 3. So really any time you have a term in the denominator, either originally or after you've done this flip and changed it to its reciprocal, you need to include it as a non-permissible value. After that, it's pretty simple. You're just going to cancel your like terms, and you're only left with, oops, that should say x minus 7. The note's online, you'll have to fix that. X minus 7 over x plus 3. Okay, and then finally, solving these rational equations, what we need to do is we need to essentially set one side of the equation equal to 0. So here I've got 16 over x plus 6 equals 4 minus x. So first thing I did, I've got a denominator here that cannot be equal to 0, so I stated my non-permissible value of x cannot be negative 6. After that, I worked to try and get one side of this equation equal to 0. So to get rid of this x plus 6 on the bottom, I multiplied it to the other side. So you can see that here. 4 minus x times x plus 6. And on the left-hand side, I still have 16. You can expand all of this and then move the 16 over to the other side and simplify. So I end up with this nice trinomial that I can factor. Now, I like to factor out, because this a value in front is negative, I like to factor that out first so that I'm dealing with a trinomial where the terms are where the leading term is positive, and then I can factor this. So the negative is out front, x plus 4 times x minus 2. And now, because I was asked for my solutions, you're going to want to state what makes this equation equal to 0. So it means if this bracket was 0, so x equals negative 4, or if this was 0, so that's x equals 2. You'll also just want to double check by looking at your non-permissible value and make sure neither of these solutions was actually a non-permissible value. And in this case, they're not, so we've got two solutions.